Open. So everybody gets electricity. Seconds, ne? So electric seconds, yes. What do you need to know about electric seconds? So I'm not going to talk about everything that you need to know on electric seconds. Eh? The most important things on electric seconds. So in electricity, mostly we talk about the Ohm's law, right? We talk about the Ohm's law. What is Ohm's law? What does it say? What does it say? What does it say? How does it say? What does it say? Hey.
The amount of electric current through a metal conductor.
The amount of current through
a metal conductor.
A metal conductor, right?
At a constant temperature, the sector is proportional to the voltage across the conductor and can be
proportional to the voltage
across the conductor and can be
conductor, right? And what else?
Can be described by what
so this Ohm's law it only works when temperature is constant, right? Temperature must remain constant. So the amount of current through a metal conductor is proportional to the what? To the voltage across it, right? So to which we use this formula when we are dealing with this, right? Current is equal to what? Voltage over resistance, right? So again, we can call this as, it depends on how much you want to write this. You can write it in any way, right? V is equal to IR or I is equal to what? V over R, right? That is the Ohm's law, right? That is the Ohm's law, right? So, what is the resistance, guys? What is resistance? What is resistance? What is resistance? If you are explaining to someone, what is resistance? What is resistance? Resistance is the opposition of flow of charge, right? This is the opposition of flow of charge, right? It opposes charge to flow, right? What about current? Current, we show current by this, right? Current, what is current? And it is measured in what? In ampere, right? This resistor, we show it like this, and it is measured in what? Ohms, right? So what is current? If you can explain to someone what is current, how can you explain this? What is current?
Flow charge.
Rate of flow of charge. So this is the rate of flow of what? Of charge, right? That is what? That is current, right? That is current. So we are going to talk about this Ohm's law and how we can use it to calculate many different things, right? So before we can go any further, I want to explain how you can find different aspects using this thing, right? Right? Can I erase it? So let's recap from what you know, right? What you already did in grade 10. right? So in grade 10 you learned about different things, which some of them I want to explain here, right? Maybe you can understand data from here, right? Right? So we are going to talk about these different things here, right? On different aspects, right? How is the series second like? So the second series mostly will represented by something like this, right? So this is a what? A series second. Can you see that? This is a series second. So this is resistor 1, resistor 2, resistor 3, and resistor 4, right? And if we're talking about the parallel circuit now, you can have something like so this is our R1, our resistor 2, our resistor 3, and our resistor 4, right? So having 4 different resistors there, right? Can you see that? So how do we calculate the resistance in each of these, right? So in the series circuit, this is how we can calculate the total resistance. We say resistance total is equal to R1 plus R2 plus R3 plus R4. Depending on how many resistors we have, it means that we can continue like that, right? Depending on how many resistors we have. And if we're talking about a parallel circuit now, we can say R T parallel, R total in parallel, right? Is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on, and then we do what? We reciprocate that, right? So we can put all inside the what? The bracket, and then we can reciprocate that, and then it gives us the R total straightforward, right? The other way that you can use, you can also say 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and then when you are done, again reciprocate this, right? Right? So it depends on which way you want to use, right? So now, if we are talking about the voltage now, right? No, sorry, the current, right? We know that the current in the series circuit, what happens? Does not, right? So it means that current here on resistor 1 is equal to current on resistor 2, is equal to current on resistor 3, and is equal to current on resistor 4, right? The resistance is, the current is the same throughout, right? The current is the same throughout there. Okay. So this is what happens, right? In the what? With current, right? And when I talk about current in this, now the current divides, right? So it means that the current here is not the same as the current there, is not the same as the current there, is not the same as the current there, right? So if you have found the total current of this whole circuit, right? The total current, it means that the current total is equal to current 1 plus current 2 plus current 3 plus current 4 and so on, right? Right? So it means that we can add all these currents that are happening here to find the total current in the what? In the circuit. Right? Is it making sense? Okay. And then we go to voltage. What happens now in voltage? Voltage here it divides, right? So it means that the total voltage that is here on the EMF, this one, right? It's equals to voltage 1 plus voltage 2 plus voltage 3 plus voltage 4, right? So it means that now the voltage that is total is equals to voltage 1 plus voltage 2 plus voltage 3 plus voltage 4 and so on, right? Depending on how many resistors we are having here, right? Okay. And then now we're not talking about this now. The voltage is the same throughout. The voltage here is the same as the voltage there, the same as the voltage there, the same as the voltage there, right? So it means that voltage it is the same. V1 is equals to V2 equals to V4 and so on, right? Is it making sense? Is it making sense? Okay. So now what we are going to do, we are going to try to calculate different things when we are having this, right? How to get? Okay. Okay. So I want to give the aspects that are complicated mostly when it comes to relevant work, right? Okay, let's take it to having this. What is this? This is a cell, right? What about now? Right? So grade level, the most complicated aspects are these, right? When we are having situations like and then they say this is resistor 1, resistor 2, and resistor 3, right? This is 2 ohms and 4 ohms and 3 ohms, right? So we're having 3 resistors like that, right? So if you can explain, can you try to explain what is happening here? Is this a series or a parallel circuit? This one? It is both, right? Both aspects are happening at the same time, right? This one is in what? In series, but these two they are in what? In parallel, right? So what happens is this. This in series adds up with the total of this in what? In parallel, right? So it means that if we are trying to calculate the total resistance now, the total resistance of this, we can say resistance total is equal to what? Resistor in what? In parallel plus resistor in what? In series. Can you see that? So how do you calculate the ones in parallel? We say 1 over R2 plus 1 over R3 depending on how many we are having there, right? Plus the one in series is what? R1. What? Yes. So it's like this, or we can write it like this, right? Yes. Yes. So this we're going to do reciprocate that, right? Right? So this is going to be 1 over 4 plus 1 over 2 and then plus what? Plus 2. What do we have here? 4 over 3. So this becomes 4 over 3 plus 2. Is 3 comma 3 comma 3 ohms. So this is the what? The total resistance in this situation. Can you see that? So it means that we can separate a circuit depending on what is happening, right? We can separate the series and we can separate with the what? The Do you have yeah. Okay, let me ask about this one. I want to hear from you. Ne? Can I raise it? Okay. So let's see, guys. We're having this situation here. Hey, Linda. Okay, let's see, what are we having? We're having it. What kind of cigarette is this?